Good morning or afternoon for those of you joining from the East Coast. Thank you for joining today's webinar brought to you by Microsoft and InCycle Software. My name is Stephanie Long from InCycle, and I will be moderating today's webinar. I wanted to let everyone know that this webinar will be recorded for future reference. Throughout the presentation, if you have any questions, please type them in the chat box and we'll do our best to respond either throughout the webinar or at the time reserved for the Q&A session at the end. Questions not addressed in the webinar will be answered in a follow-up email. Now let's get started by giving you a little information about who we are. We've been around since 2002. We're a Gold ALM and also Cloud Partner. We're focused on TFS-related services such as installation and migrations, release management, and agile tool training. From the Azure perspective, we also perform related services such as infrastructure setup or application migrations. These are just a few examples, but we really cover the full ALM, DevOps, and Azure spectrum. We have consultants across Canada and the US, so we most likely have someone in your area. Now, before we get started with today's webinar, I'd like to introduce you to David Pitcher, who's one of our senior consultants. David is a lead technical consultant on Visual Studio, TFS, and Azure. Prior to InCycle, David was at Microsoft for 15 years, and he's a distinguished ALM Ranger. Over the next 45 minutes, David will be providing an overview of Azure networking services, capabilities, and best practices. Now over to you, David.
All right, thank you, Stephanie. Good morning, good afternoon, good evening, everyone. Thank you for attending. Hopefully this session will be rather informative. And so let's skip to or jump right into the agenda. So I want to talk to you today about networking services or features around Azure networking, how to use them, why would you use them. The first topic we're going to cover is around cloud connectivity. So how do I get my customers or how do I connect or you connect to Azure services? And through that connectivity model, it's going to be either Azure Virtual Networks, and then once that network's set up, connecting using point-to-site VPNs, site-to-site VPNs, and we'll also cover some details around ExpressRoute. We also want to talk about highly available services. So how does Azure Network Services or capabilities give me or help facilitate creating highly available applications or services? And that's going to be through the Azure load balancing mechanisms and also Azure Traffic Manager. Third, we'll talk about IP addressing. So this is an important aspect around virtual networks and my planning. So something you may want to really consider looking at adopting Azure and creating your virtual networks is bringing in your technical resources or architectural resources that do your network mapping for on-premise. So we'll talk about virtual IP addresses, the static or dynamic internal IP addresses that get associated with Azure services and VMs, and also the public IP addresses that you can attach to Azure services. And then finally, a very big important aspect of Azure is security. So how do I control access to the network resources? So I don't want to keep my network completely open. I want to look at being able to provide access control lists to individual endpoints or load balance sets. I want to look at network security groups on how they apply, and then also a brief look into how I can do some network security using multiple NICs assigned to VMs. And then finally, we'll wrap up with a Q&A session. If you do have an important question during a presentation, please feel free to enter it in the IM window, and myself or one of us will try to get to that question. If not, we can wait until the end to the Q&A session. So cloud connectivity. We're going to touch on these 4 points again, and it's really about how do I connect as a customer or my users to the Azure services that are being provided. And the base of this connectivity is going to be through Azure Virtual Networks. And then providing connectivity through virtual networks through either a point-to-site, site-to-site, or ExpressRoute. So what are virtual networks? They really are an extension of your data center on-premise. It extends the enterprise networks into Azure. So it's an extension, or think of it as an extension. So you have private IP addressing that you use for your internal data center networks. So these are the 10.000 Class A, the 172.16 Class B, and then the 192.168 Class C private network. So all of the Azure networking is based on IPv4. So keep that in mind as you're planning your networks. The virtual networks also provide the capability of ramping up or migrating existing applications and services over to Azure. They also enable hybrid applications. So connectivity options to provide reach and access from your on-premise network or data center into the Azure network. They provide logical isolation and control over networks. So you can distribute applications to different nodes or subnets, or even multiple virtual networks. You have full control of managing the IP address ranges and subnetting within your virtual network, and you can have more than one virtual network. The virtual networks are stable and persistent to your Azure subscription. They also allow you to bring your own DNS servers or leverage Azure DNS. So, for example, if I were going to create an extension to my on-premise and put some applications out there and I wanted hybrid connectivity, I may put a DNS server specifically out in my virtual network as a VM, or even an Active Directory server, and between the combination of Active Directory and DNS, I have direct machine routing and lookups within that Azure virtual network as part of my on-premise network now. Or I can leverage the out-of-the-box Azure DNS capabilities and services. Virtual networks are all securable. Again, they're not internet routable, so by its very nature they're secured, but we can control access to those virtual networks and how the endpoints or specific ports are mapped on those virtual networks using ACLS or the network security groups, and that will be a complete topic in itself. Another nice aspect of virtual networks in Azure is I can create multiple virtual networks. I can create many virtual networks within a data center or span them across multiple data centers and provide connectivity through them. So VNet to VNet connections. And those VNet connections are done using IPsec, VPN connectivity. So that provides, again, a private link between those virtual networks, and it gives me the ability to create some very strong isolation and security across that networking infrastructure for tiers of my applications. Or if I want to produce an application that's multi-tenant and have that hosted in Azure as an example. Or if I want to distribute it across multiple regions across the entire Azure infrastructure. So if I'm a global company or I need to support global services, I have that capability and provide network isolation that way. So I could have a virtual network in US West and have a complete duplicate of my application in, say, US East, and create connectivity between those. So if I want to do log shipping or data replication. So definitely, again, we are able to create not only within a region, but also across regions for communication. So as we look at your networking infrastructure, it's great to get the network administrators engaged early and start the planning. Primary reason for that is you want to avoid network IP address conflicts. Because most likely your private network or data center is going to use the same non-network or internet routable network addresses, so you don't want those to overlap. So it's important to get those folks involved early on in the conversations and discussion, especially if you're going to be implementing hybrid network connectivity or connecting your on-premise or some other form of private network in a location to your Azure cloud network. And those primary means of connectivity are either through a secure point-to-site or a secure site-to-site. Let's talk about why I would want to choose one over the other. A secure point-to-site really is meant for individuals themselves to establish VPN connectivity into the Azure network or the Azure ecosystem, targeting to developers or individuals that are maintaining certain aspects of that Azure ecosystem. Very small-scale deployments, or if I need to connect from anywhere in the world, that secure point-to-site connectivity offers value. If I need connectivity from a very large segment, or I'm a small, medium business, or even in the enterprise space, I'm going to want to set up and establish a secure site-to-site VPN connectivity. So that's one connection in which all users have access. And so it's basically joining through that tunnel my on-premise network infrastructure to my Azure infrastructure. The VPN connectivity is done over IPsec. And the site-to-site is more about supporting IaaS and PaaS workloads. So platform as a service or infrastructure as a service. So PaaS in the Azure sense, think of Azure Cloud Services, worker roles, web roles, and then the IaaS sense, think of VMs. But what if I need more? This is where we get into a private site-to-site connectivity through ExpressRoute, and I would want to look at that type of connectivity if I need dedicated or very specific bandwidth. It's for mission-critical workloads, backup, disaster recovery are another prime examples. So let's dive in more into each one of these and see what they look like and have a visual representation of how these actually connect and work together. So point-to-site VPNs. I have my on-premise data center and, of course, the Azure cloud and its virtual network configured. Now I need to allow individuals that are on my on-premise network, they log into their machines at work, but yet they need to access some of those Azure resources. There's no connectivity from my primary network. I want to keep that isolated. So enable point-to-site connectivity. So users sitting in my data center or in a location logged into your corporate network create additional logins or connections through VPN into the Azure network. We also can enable remote workers or partners that don't have access to your on-premise network or information, but need to access information out in Azure. So there's another scenario where point-to-site VPNs really showcase and stand out and provide that necessary capability. One thing to keep in mind with a point-to-site VPNs is each connection is opened up by every user. So it's consuming IP addresses. So keep that in mind as you're planning your choice of VPN connectivity. So we have a question. Multiple or a couple on-premise servers which I need some VMs to be able to contact. What's the best route to follow? If it's multiple VMs, again, it depends on how many people. So I look at the scale of people that need to connect. If it's only a few people, point-to-site VPN connectivity will work. Need to enable a much larger audience to connect to them, then I'd recommend moving to a site-to-site VPN connection. And your VMs, the way you would do that is put each VM within or all your VMs within a cloud service, even a VM per cloud service. That connectivity is still there. Those VMs have to be assigned into an actual virtual network in a subnet. And site-to-site is going to go to a specific VPN gateway, and that VPN gateway maps to a specific virtual network. So when you create a VM, you're going to establish which virtual network and subnet those VMs belong in. And you can also create multiple VPN gateways if you need to segment that out. In that scenario, I definitely recommend a site-to-site type VPN connection. So another question is point-to-site VPN connectivity something that could be used for software developers to be able to connect to Azure resident databases from the local instances of TFS? That is an option, and I recommend the choice between point-to-site and site-to-site and the number of developers. It's TFS Visual Studio within that IDE, and you need to connect to a database to deploy to it or manipulate it. And I'll repeat that. I do recommend point-to-site if it's a small handful of folks, because what you have to do is manage those connections, or those VPN connectivity connections. If you're much a larger organization, I'd want to create the site-to-site VPN, so I'm not asking each user to create a different VPN connection out into my Azure services or what I have in Azure and they need to access. So it's more of, do I have a larger IT organization that can handle that, or would I want to go with a much smaller one? Or if I want to separate out, say, partners that I don't want to connect. Okay, site-to-site VPN connectivity, exactly the same as point-to-site, except for all the traffic of my on-premise and individual users that need to access Azure go through one VPN tunnel instead of multiple for each one. So you can open up that larger gateway, get a little bit more performance based off of that, and aggregate that up. So you're not asking individuals to create individual connections. And that VPN gateway is also mapped to each virtual network. So with Azure, again, you have the ability to create multiple virtual networks. In those scenarios, you'd create multiple VPN gateways and create the correct routes. And in this scenario, I also want to talk about, I do have a site-to-site, but I can also still support point-to-site VPN connectivity. And then finally, ExpressRoute. Where does ExpressRoute play in? Is IPsec over the internet is what the VPN connectivity that you normally have is. So it's not connecting to your network directly. Your private network is now creating a tunnel across the public internet into Azure Cloud. So you have limited bandwidth. So you're restricted to the amount of bandwidth that your public internet connection is. You're also going to experience greater networking costs and latency over this type of connection. By moving to Azure ExpressRoute, I'm going to remove the connection to the public internet. I'm going to connect the Azure Cloud Virtual Network directly to my private network and WAN. So with this, I'm actually removing any dependencies on the public internet. I have much higher availability, lower latency, and higher bandwidth. So this is a definite option if you need that type of security and performance or network performance. So how do we get high availability for our Azure ecosystem and the services we offer out in Azure? The first we'll look at is load balancing. There's a couple load balancing options that are part of the virtual networking in Azure, and then we'll also look at Traffic Manager, which is an additional service that provides robust load balancing, monitoring, and availability. So first we'll look at the Azure Load Balancer. One of the misconceptions around that is it's a round-robin type of load balancer. It really is a layer 4 network protocol algorithm-based load balancing. It's kind of similar to how round-robin works, but it uses an internal hash algorithm to do the load balancing itself based on 5 tuples. And we could talk more in detail about that and how it's done in terms of it's got a source IP, source port, destination IP, destination port, and it uses a combination of all 5 of those tuples to determine which internal endpoint to go to. And with that, you can also create multiple endpoints that are the same port, and that's through a load balance set, and that normally goes through the Azure Load Balancer. The load balancer, or the Azure Load Balancer, is really set up for IaaS and PaaS tenants. To configure the load balancer for PaaS tenants, that's going to be through your cloud service model or your CSDEF, if you're familiar with working with cloud services. For those that are using it for IaaS tenants, you can configure some of it through the management portal, and it's preferable through either Azure PowerShell or the Azure APIs to do a lot of the load balancer configuration. The load balancers can support multiple endpoints. So each cloud service or VM can be configured with multiple endpoints. And the differences here is the endpoints must be different port number and protocol. Make sure the port and protocol creates a unique endpoint. And as of right now, there is a maximum now amount of 150 endpoints per service that you can define. So I really don't see 150 as being a restriction, but just keep that in mind as you start planning out your network usage. Load Balancer also provides a level of service monitoring through probes, or what they call health probes. You can have an HTTP health probe, which requires a specific URL that the load balancer will monitor, and a TCP health probe, which is going to listen to and send responses to a specific port. One nice thing about the load balancer and its health monitoring is with those probes, for instance, on an HTTP probe, if you send a response to that URL and don't get the right response back, the load balancer will take that failing instance out of the load balancer rotation automatically and continue sending out the health probe and keep monitoring that. If it comes back available, it will bring that machine or that VM or service back into rotation. The same will work for the TCP health probe. And finally, source netting or network address translation. So this is regarding all outbound traffic from a source IP. It will end up using the virtual IP address for the outgoing address. The 2 types of distribution modes that are supported with the Azure Load Balancer. The first one we have already somewhat talked about is the hash mode. And that, again, is an internal algorithm on the load balancer that determines the end service or virtual machine based on that 5-tuple hash. So the load balancer looks at the source IP and port, destination IP and port, and a specific protocol, and then makes a decision on which VM or service to use. A relatively new distribution mode is the source IP affinity, or IP affinity mode, and it's based off of a 2-tuple hash. So it's going to look at the source IP and destination IP and keep sending requests to that specific virtual machine. So you have some form of affinity, and that is selectable and configurable. Looking at a sample load balancer configuration, say for a cloud service. So we have a series of load balance ports and several VMs inside. And on the load balance ports, those are now all sent equally or through a hash distribution model to each VM as needed. So we have a couple HTTP maps, and those will rotate between the two VMs that are mapped there. Also TCP and UDP to show that those work for load balancing. And also you can have individual instance endpoints. So in this scenario, we can have, for instance, HTTP port 10,011, and that is specifically mapped to VM number 2. So it won't go through the load balancer. So you have multiple choices on how you do your endpoints, as having them participate in the load balancer and not. The other load balancing option with Azure is an internal load balancer. This is something that you'll have to manually configure using PowerShell. And one of the nice capabilities is providing multi-tiered service within a singular cloud service. So in this scenario, we're taking SSL port 443, distributing and using the Azure load balancer to distribute across a web tier series of VMs. But now I want to use an internal load balancer to distribute the backend database load. The internal load balancer behaves the exact same way as the Azure load balancer. It's just an additional load balancer that you can configure. You cannot configure the internal load balancer using the management portal. You must use the APIs or PowerShell or the XPlat if you're looking at a Linux or another type of platform that you want to configure. The other good thing for the internal load balancer to use it for is to spread and provide load balancing across multiple cloud services. This comes in handy because cloud services and VMs have some forms of restrictions. So some larger VMs must be in a specific cloud service. I can't mix and match an A1 and an A8 in the same cloud service. So I could provide some form of isolation and virtual networking and connectivity of creating multiple cloud services and using the load balancer to route between those. So in this scenario here, I can have a cloud service made up of smaller VMs for my web tier, and then go to much larger A8s or A9s for a database tier and distribute load across those. And then you can see that's all wrapped up within inside a singular virtual network. So Traffic Manager. I really think this is an important item to consider in Azure service to help with load balancing and high availability. Some of the key aspects of Traffic Manager are the ability to help you reduce application downtime. So Traffic Manager can improve the availability of important applications by monitoring them, either for Azure or external sites and services, and automatically directing users to a new location anytime there's a failure. So again, with Traffic Manager, you can configure it for how it's monitoring. So this is similar to the load balancer health probes, and ability of Traffic Manager to detect when a site or service is not available. Improved application performance or delivering content. So Traffic Manager can be used to make applications more responsive and delivering content back to the end users by looking at network latencies and the relative nature of where the user is to where that service is, and being able to choose the closest service or the service that's connected to a network with the least amount of latency. So you're improving your overall application response time. to distribute user traffic over multiple locations. So if I'm geo-distributed or have multiple locations for my services within an Azure data center, or even for websites and different data centers, Traffic Manager can distribute that load either equally through a type of round-robin distribution or even a weighted load distribution or weighted round-robin. Traffic Manager allows you to work with your on-premise data center and with cloud, so you can do a hybrid approach here. So some of the scenarios you could think of for on-premise is, say, burst to cloud, migrate to cloud, or even like a failover to cloud from your on-premise. So if I'm reaching max capacity in on-prem, I can have any type of additional capacity allocated automatically in Azure and Traffic Manager route to there or distribute the load to there. I can use it for migration of my on-premise app to cloud. So gradually, slowly move over using Traffic Manager and segmenting my users between my on-prem and my cloud infrastructure, or even failover to cloud. The ability to detect a failover for your on-prem service and then have Azure start up a new service or capability and then use Traffic Manager to direct to it. So you're going to limit overall perceived downtime or even implement a maintenance program for your on-site data center. So how does Traffic Manager work? Well, the first one is taking user traffic and out to your company's domain name or DNS server. Within there, you're going to have a lookup, or what we call a reverse lookup, to translate your regular domain name, in this sense, say www to contoso.com, and translate that back to contoso.trafficmanager.net. So DNS request is going to redirect to the Azure Traffic Manager for your domain, and it's going to read and pick up a Traffic Manager profile. And the profile contains a list of rules or decisions of how to route the traffic that you develop. So you actually develop the profile itself, or a series of rules that direct Traffic Manager to make decisions. So once Traffic Manager evaluates all those rules, it sends a response back or an actual correct IP address or resolution to where that endpoint is back to the user. Then that redirect takes place automatically, and the user is directed to the appropriate cloud service, website, or VM. So in a nutshell, that's how Traffic Manager works. So what are some of the scenarios in detail that we talked about before that Traffic Manager provides significant value? One is in failover, because Traffic Manager is monitoring all those endpoints. If one of them happens to go offline from health reasons, or even say for maintenance reasons, I want to deploy a brand new version of my code, I can deploy and take my primary site offline, leave my standbys online, deploy to my primary, and let Traffic Manager know that it's offline and distribute the load to the standbys. So I can do rolling updates or rolling upgrades to my application or services and really reduce downtime to almost be zero downtime, or actually zero downtime. The weighted or random round robin type scenario, again, I have multiple cloud services here. Traffic Manager just is directing traffic in a random way if I do not apply weights. This is going to pick and choose what's available, or I can weight it. So I can target, in this case, Cloud Service C with a higher weighting. So I want the majority of the traffic and requests to go to that cloud service, and the rest of the cloud services are distributed with other different types of weighting. So it gives me the ability to primarily target a singular machine or service, and then have the rest of the load equally distributed in a smaller sense. I can use this to even roll out new types of features or capabilities. If I wanted to, and roll out a new feature, I could push that new feature out to Cloud Service D and give it a weight of 1 and increase the weighting on all the others. So a smaller percentage of users would see that new feature and use it and can evaluate it. So that's another type of scenario where this round robin or weighted traffic manager routing can take place. The big one is around performance, especially if I'm working in a distributed global reach for my services and applications. I can have, in this scenario, we have our cloud services distributed in East Asia, Europe, US East and US West Azure data centers. And I have customers all over the world coming in to reach those services. In this scenario, I have a customer that is in some West European region. And based on the DNS server, Traffic Manager is using that to detect where they are from a geographical point of view. Traffic Manager is maintaining a latency table based on IP addresses and ranges, and what the performance is like across all the cloud services and data centers that I have deployed. So when a request comes in for a specific service, Traffic Manager is going to evaluate based on the end user's DNS server and evaluate the network latencies and choose the best cloud service to respond to or connect the user to. So the one with the least amount of latency scenario is going to be West Europe. So that's what they get pointed to. Guaranteeing or driving customers to the best network connectivity possible based on where they are at geographically and the current latency tables that the Azure Traffic Manager is. So that covers the high availability options around Azure networking and the two key scenarios, the load balancer and Traffic Manager, that help provide those capabilities. So let's move into IP addressing. How does that work within Azure? The different flavors. So we have virtual IP addresses, reserved virtual IPs, static internals or DIPs, and also public instance IPs or PIP. So how does that Azure addressing work? So within a cloud service, you have your VIP or virtual IP address. This is an internet routable IP address, and it's Microsoft owned and randomly assigned to a cloud service. So for every cloud service you have, it has a singular VIP. And then how do I connect that VIP and that cloud service back to my VMs? And that's done through a combination of virtual IP import being mapped to an internal IP import. The VIP itself, as it's assigned, is stable during the lifetime of the cloud service and the VM lifecycle. So if I shut down and I have a singular VM and it's directly connected and has a VIP and a cloud service, if I delete that VM, that cloud service has nothing in it anymore. That VIP still is maintained as long as that cloud service is alive. If I remove the cloud service through the management portal or API or PowerShell, then that VIP goes back into the pool. And if I create a new cloud service or recreate that cloud service, I may get a different VIP. So you can keep in mind that the VIPs are attached to the lifetime of the cloud service. And then through the Azure Load Balancer and internal Azure infrastructure, cloud services and VMs are assigned a DHCP least-based private IP address. You can specifically specify one based on adding a VM into a specific subnet, or it's randomly assigned if that VM is not assigned into a subnet. The dips themselves are stable during the life cycle of the VM. So once I create the VM, Azure will automatically assign it. It's a long-time lease, or the lease of the lifetime of VM. So if I stop my VM, but do not shut down the VM, I still maintain that IP address. If I shut down or deallocate that VM, next time I start it up, I will get a different internal dynamic IP address based on how Azure wants to assign those and the subnet that it belongs to. So a reserved IP address. Why would I want an RVEP? Reserved IP addresses exist for the lifetime of a subscription. So if I want to use very specific known addressable IP addresses, I can use reserved, and then assign a reserved IP address to my cloud service. I need to maintain it because I may have DNS rules or DNS routings around that RVEP. And I have much more control over any of the VIP outbound traffic. So any other routes or, again, DNS or other types of networking services that are dependent upon that IP address being static or the same no matter what. So using RVEP, there are some constraints. It's for VMs and cloud services only. By default, there's only 20 reserved RVEPs per subscription that you can request. You can make special requests through Azure support to get more, but that's at current what the default rate is 20 per subscription. You can only have one RVEP or reserved VIP per cloud service. The first 5 are free. Anything after that, you're charged an hourly rate for those reserved IP addresses, regardless if they're being used or not. Once you get them allocated or created, and if you're using them on a cloud service or not, they still charge for that. It's a very minimum fee, but if you're using a lot of RVIPs, the price could add up. So just keep that in mind if you need to use reserved virtual IP addresses. The other type of fixed IP address or static is going to be your static dip or your static internal. So there are several scenarios in which you would want to create a VM that's got a fixed IP address that Azure doesn't assign when the VM is started or after every time you deallocate it. These scenarios would be, say, for a DNS or domain controller. The most popular one I've seen and used is in the needs of a domain controller. That's got to have the same IP address every time it starts up. So this way I can shut down the VM and deallocate it, and then I can create it back again and guarantee that it'll have the same IP address. And to configure this, it's not done through the Azure Management Portal. It's easier to go through when you create the VM and assign that as part of the VM creation using PowerShell or the API. Public instance IP is a way to assign an internet routable IP address directly to a VM. There's only a constraint of 5 pips per subscription, so you can't request more. That's all you get. And, of course, there's a fee for each one that's being used. The biggest usage for this is passive FTP or dynamic port selection. Right. Network security. The first one we want to look at is ACLs on endpoints, then network security groups, and then multiple NICs. So with network ACLs or access control lists, it's the ability to specify an IP address or IP address range and grant it permissions to come and speak to or connect to virtual machines. So this is the default without any ACLs. Any IP address or range can communicate to VMs through the endpoints that are created. So that's the port and the protocol. Now, if I want to have more control over that and restrict who or what segments of IP addresses can connect, I'm going to create network access ACLs. So I could take an IP address range, either it's a full fixed IP or using some wildcards. I can create the ACL and grant connectivity or allow that to pass. So think of this as creating firewall rules. Then I can deny traffic from other segments and do that explicit per VM. So if I wanted to create an RDP port and allow a certain number of people to access that RDP port to a VM, and say I know my internal or a specific gateway for my on-premise network is in the IP address of 127.255 star, that entire range, so anyone with that originating IP address can actually connect to that VM. All others are blocked. So you have multiple ways of creating those endpoints. You can actually create explicit permits and deny permissions and any combination thereof. And as you order the rules, it will start at the top and work its way down. So that's the order of precedence. So you can reorder the rules, but they're always going to execute in that same order. Also keep in mind when using ACLs, you can have 50 ACL rules per endpoint. If you're creating an endpoint or an ACL that is on a load balance set, so that's, say, port 443, and it's being load balanced to one or more VMs, then that ACL rule applies to all VMs in that load balance set. A better alternative, instead of ACLs, is leveraging network security groups. Network security groups is a 5-tuple type of security implementation or designation. It's based on the source IP import, destination IP import, and a specific protocol with allow and deny. So this gives me the ability to segment my virtual network into specific regions or subnets and control how communication can occur between those subnets. So in this scenario, the diagram is depicting the ability to create a DMZ. Whereas my domain controllers and DNS sit in a relative open DMZ zone, then my web proxies are in a front-end subnet, my data is in another subnet, and my back-end is in another subnet. Through the network security groups, I can control how those subnets speak to each other, or incoming traffic is distributed and is reachable. So in this scenario, the web proxy or machines in a web proxy subnet or the front-end subnet cannot talk to the data subnet directly. The only way they can work through is because of the network security group is talking to or sending traffic to an internal load balancer. The back-end subnet is allowed to talk to specifically the internal load balancer and the data subnet. So now I can create some very rich network isolation and security. And network security groups are the primary way or recommended way of setting up additional security and management around network connectivity. And finally, multiple NICs. For every virtual machine you can create, you can add one or more virtual NICs onto that machine and configure them to address or have access to a specific subnet in your virtual network. There are some restrictions to this, and it's based on your VM size, on how many NICs you can have attached. One key thing to keep in mind is your additional virtual NICs that you assign do not have access to the virtual IP address. That virtual IP address is assigned to the default NIC. So the only egress that you're going to get is across the default NIC. So that is another mechanism if you want to provide very restrict or custom addressing. on a VM and access of services distributed across subnets. So out of all those options, I'd say multiple NICs is the least preferable. It requires a lot more maintenance, PowerShell scripting to actually do this. It's not exposed to the management portal. You can do it through API also. Okay. All right, so we'll leave up the last 10 minutes here for any questions that folks may have. And I thank you very much for attending. Hopefully this has been informative and is giving you some answers to your questions around Azure networking services.
Thank you very much, David. I see 2 questions are coming in here. All right, while you're typing in any questions you may have, I'm just going to move on to some offers. So with your Visual Studio with MSDN, you can get a number of free subscriptions, such as Azure, Office 365 Developer, and a Windows Developer account. This is also a great opportunity that Microsoft is offering up to 5 days of professional consulting to help you with a proof of concept to show how you might migrate your applications to Azure. And then the last one I want to mention is with Microsoft Azure Deployment Planning Services, InCycle can help you roadmap how to move your enterprise to use Microsoft Azure. One question coming in, David, is if I have an Azure web connected to Azure VM Resident DBS, why would I need a third-party firewall in front of the Azure VMs?
So
he said web app, that is, sorry.
Sure. Just to clarify and repeat, we're looking at either an Azure web sites or a web VM or web apps hosted on a VM. And why would I want to firewall, or why would I need a third-party firewall in front of the Azure VMs? So if I'm understanding that correctly, it's the scenario that you're looking at is you're looking at using the Azure load balancer or internal load balancer as a firewall, or not that, or some other type of service that's in the Azure marketplace to behave as a firewall in front of those VMs. So Benjamin, if you could describe which one of those scenarios. Okay. So getting additional clarification here. I think at this point, if folks want to unmute with their question, as long as we don't stomp on each other, I think that would be fine if it's easier than typing in the IM window. Stephanie, I don't know if each folks can individually unmute or not.
I'll go ahead and unmute the audience. I went ahead and unmuted the audience if anyone wants to talk.
David, this is Benjamin Flowers. I had the question about firewalls and Azure websites and databases. Can you hear me?
Yes, I can. Thank you.
Great. Thanks for taking the question. What I'm really trying to get at here is I actually don't see the need. I don't see the need for something like a Barracuda firewall in front of an Azure VM that is in the same VNet as my Azure web app. That seems I guess, superfluous to me, but I want to make sure that I'm correct about that. And if I am correct, if there's a succinct reason that I can give for that.
I don't see a need for say the Barracuda firewall in place of this. So the Azure VM is going to be completely protected from a non-addressable, because it is a non-addressable network. And to communicate with it, you have to explicitly enable the endpoint back into that VM. And with that, you could easily set ACLs on there, so originating traffic could only come from, say, that website or web application.
Okay. So I would just need to set an ACL endpoint to. Now the thing is my Azure web app is also in the same VNet, so I don't even know if I need to do anything. As long as my the front end to my web app is secured.
Correct.
Yeah, that's all I need, right?
Yep, and if you wanted to go more control, again, you could create a network security group or an ACL to explicitly limit that.
My web app has to be publicly available from the login page to the web app has to be publicly available to anywhere.
Right, but the internal application itself, so if your web application is, say, creating on one of the pages, say it's an ASP.NET code behind, and it's creating a database connection.
Right.
So your IP address, internal IP address of that web app, you could put an ACL on the VM to prevent anybody else from talking to it. So you're only granting the internal IP address of that web app from communicating to that VM over that specific endpoint.
And then if I have some sort of legacy app, like say maybe a legacy click once app or something like that, that needs to access those same databases, then is that where the ACLs would come in?
That would be the ACLs or network security group, or even just the Azure load balancer.
Okay.
Because that in itself is layer 4, and it can behave as a firewall.
Okay, perfect. I just want to stick with. It just seems like Azure, has all the, I guess, capability set that I'm looking for security, and Barracuda just seems like we're throwing something up that we don't really need. So I just wanted to see if I was correct about that and what the details were. I appreciate your time. Thank you.
Yep, you're welcome. So Reza has a question around what in terms of load balancing, and it's usually user affinity or sticky sessions. So that once you go into a load balance set and how you do that. So if it's ASP.NET, creating ASP.NET session state is not really looked upon. You're better off going back into using view state to manage that so you can scale over a load balance set. If view state's not working, again, with the Azure load balancer, the way that works, you could set up with a source IP affinity. So all originating requests for the duration of that network session or that network connectivity is always going to go to that same machine. So the Azure load balancer has those two options. So if you're having problems with sessions or session affinity, when you set up the load balancer and that load balance set it up to use source IP affinity. And then Scott has a question on cloud services and VMs. So Azure websites, from anything from the website back into other Azure resources, you can control, but not access directly to the websites themselves. So that's a whole different mechanism that Microsoft is using to provide public connectivity to those Azure websites. So hopefully that answered, Scott, your question around the isolation.
Yeah, Dave, can you hear me okay?
Yes.
Okay, so if I want to set up like internal web APIs, like using the new API apps, is there any way to shield those from the internet, or if I'm deploying as an API app, then it is going to be publicly accessible?
As far as I know, any API app or website, it's publicly accessible.
Okay.
So, Dave, this is
Azure
Harris.
Websites. Okay.
I was going to say the other thing is the Azure apps that just recently announced, I guess maybe 2 weeks ago or so. There is a way they talk about having restrictions on API services themselves. This is something fairly new, and I personally haven't gotten a chance to play with it, but you can, at least what I've seen documentation-wise, it does seem to be a way of restricting who or what can access the API services. But I'm not sure exactly how they do that, whether it's based on authentication or if it's I know that one option is only my other app services can talk to the API services. I think that's still growing, and it is in preview at the moment, at least last I saw. So, there may be something in the future, but right now I think that it may be kind of limited as to what restrictions you can do on limiting access to API services.
Okay, thank you very much.
Hi, David.
Harris.
Hi, David. This is Salam. I have a couple of questions.
Okay, go ahead, Salam.
Yeah. So, first question: Can we load balance to caching services in Azure? According to are you aware of this?
I have not looked at caching services and how their networking infrastructure is configured.
Well, when you create a caching services, you can, of course, you will be provided. For example, if you have a 10 gig of application services, you have 5. In fact, you have 5, and the data are backed up on the second 5 gigs. So in case something fails, them. But what we need, we have a scenario where we need to load balance 2 of those services.
I am not aware of how those work. So the Azure Load Balancer themselves specifically work with IaaS and PaaS.
IaaS and PaaS. Okay.
Right. So PaaS would be specifically cloud services themselves, so web worker roles. And then on the IaaS side, any cloud services hosting a VM inside of a virtual network and subnet.
Okay. And the second question is that what I asked in the beginning is that regarding what is the appropriate site-to-site or point-to-site architecture. We have a customer who has a router that is not compatible for doing site-to-site, and we need some machines. We need to make some VMs communicate with a couple of servers inside on-premise. So with point-to-site allows communication. I'm not talking about RDP or doing anything by users. I have a couple of servers like Puppet and Chef, which I need. They can communicate with VMs, 10 machines on Azure.
Right. So in that scenario, I would look at setting up a local Windows VM on the on-premise site and using that as the tunneling gateway VPN connection. So it doesn't have to be a specific hardware piece. It can be a VM that you use to establish a site-to-site connectivity.
Okay, so we can do the site-to-site using a machine, not necessarily a router.
That is correct.
Yeah, that was one scenario I didn't get to cover, but yeah, site-to-site works with RAS with Windows Server 2012 and higher. And depending on the scenario, there may be other options too, but that's definitely one as well. Obviously, it has to be public-facing, or it has to have some public-facing endpoint, right, in order to allow that traffic back and forth. But that would be one option.
Yeah, can you point me to some documentation on this on MS
Sure.
site? Yeah, please.
Yeah, Dave, I'll take care of that.
Okay, thank you, Harris. And
Yep.
Solomon, the other option, it's probably overkill for what you need, is looking at ExpressRoute.
It's overkill. It's really overkill. It's a small, very small company with 50 guys. They have 5 to 10 developers, and the investment is very difficult with them.
Right, okay, yeah, and so the link that Harris will provide is definitely the way to go, is using a Windows machine as a VM out in the DMZ zone, if you will, of that network to establish that VPN connectivity.
Okay. Thank you very much.
You're quite welcome.
Okay, are you going to share the slides?
Yeah, they will be available afterwards. I will email everyone with the link as soon as I upload it to our Vimeo site.
Thank you. Thank you very much. And great session. Great session. Thank you very much.
Yeah, thank you very much, Dave. That's all the time we have now. And I just want to thank everyone for participating. And thank you again, David, and the folks at Microsoft for supporting this webinar. So as we conclude, I just wanted to remind everyone to follow us on Twitter at InCycle Software or on LinkedIn for more upcoming events. And thank you again for joining, and we hope to see you soon.